Hi everyone, a quick intro on my side. I'm Neetu Sankari, work for Pfizer as a statistical data science and analytics submission and standards team, focusing on development of innovative interactive tools and packages that help us to expedite review and submission at Pfizer. Academically, I have PhD in computer science big data analytics. I'm also leading Fuse working group collaboration with FDA and ASA on clinical visual analytics for review and submission under data visualization and open source technology. As you know, there is a great collaboration with PharmaVerse and Fuse. Many thanks to PharmaVerse that we are delighted to share that admiral vaccine package, that is extension to admiral package for analysis data model in RSet library, is available on CRAN. I'm privileged to lead Admiral Vaccine Project collaboration with Admiral sponsors, our team members across pharma, Pfizer, GSK, and J&J. I would like to share key names that will help us to move forward with the package development successfully. Many thanks to Ben, Ross, who shared their Admiral package experience and support throughout the project. As a maintainer, Sukalpu, as a developers, Vikram, Arjun, Devya, Federico, Yamini, Elsa, Kalyani, Ben as a reviewer, as well as Stephen and Ed, other contributors, as well as the subject matter expert, Abdul, Jayashri, Jagdish, Ankur, Andrea, Daniel, Rania, Lee, Elda, Marlene, Mandy, and Tina. Thanks to all Admiral family and community. Last year in October, we started this Admiral vaccine package journey and completed our first release on CRAN in June 2023. We had a great experience in learning, sharing, and working together across pharma. And we encourage everyone to join our Pharmaverse and Fuse family. Stay tuned. We will share our phase 2 in few months. Now I'm passing to our teammates to walk through the package. Thanks a lot,
Hi
everyone.
everyone, this is Vikram from Pfizer. So I'm going to give a short introduction about the advanced vaccine package, which is the extension of Admiral Core package, which we developed recently and released it into CRAN. So the purpose of this package is to create vaccine-specific ADAM datasets, which includes AD-phase, ADCE, ADIS, as well as vaccine-specific ADSL. So these datasets were created by following CBER guidelines, vaccine therapeutic area user guidelines, as well as ADAM IG. So this package is built in such a way to abide by common industrial standards. So any company can make use of this to create vaccine-specific ADAM datasets. Also, we started this journey with internal discussion and came up with some common specification as well as programming flow, and we built in a new functions and the respective unit testing scripts, followed by a GitHub process to release it in CRAN. And we also had an extensive validation done internally and by Admiral to ensure the quality output. So to start with ADSL, we have created vaccine-specific ADSL by utilizing Admiral Core package, but we have made use of like minimum of it. So here we can see the programming flow for creating a vaccine-specific ADSL datasets. So if you see the Admiral Core package programming flow for ADSL, they would have many steps added in that, but we made minimum use of it. So in this case, we just made use of only EX and DM datasets, and we created like treatment variables, date and timing variables, as well as period variables. And here like the only important thing is we have just created one new functionality for vaccine specific ADSL, which is used to create vaccination dates for every subject per vaccination. So this is the function. So it is derivvax underscore vax dt.r. So this function mainly, yeah, we get the date variables from ex date variables. And also like you can look into the template like how we have made use of the admiral core package to create ADSL here. So like we have like followed most of the admin core package functionalities to create timing, date, as well as period variables. But the only thing we had new in it is was this derivax vax dtt function, which is used to create the vaccine date variables. So you can just modify these templates or to get your desired results.
Hi everyone, this is Divya Kanagraj from Pfizer. Now let's walk through ADIS and ADCE dataset. ADIS is an immunogenicity dataset. Immunogenicity is nothing but the response of the foreign substance like antigen that provoke immune response in the body. This domain actually covers test results like serology in the BDS structure dataset. ADIS uses IS-STTM dataset as input. Now let's walk through the high level programming flow. So this starts with reading the data, merging the supplementary IS domain with main IS, creating timing and date variables, followed by parameters, eval, baseline change, criterion flags, treatment variables, and then finally merging the ADSL core variables. So this in this domain we had created two new functions other than the core admiral package. So one is to create eval variable for ADIS dataset, and the other one is to create criterion evaluation flag for different criteria. So let's go through the template. So this is the sample script to create the ADIS dataset. So as you can see here, we have made use of mock STTM datasets for which we have created for vaccine, but this can be updated and the function calls also can be updated as per your study data to get the desired output. Now let's switch to ADCE. ADCE is a reactogenicity dataset. Reactogenicity in clinical trial always gives the response of the vaccination to create common adverse events. The adverse events that happen after every vaccination is monitored or recorded by the vaccine recipient in the form of e-diary, which are categorized as local and systemic reactions. So ADCE follows flat model as per the CBER latest guidelines and also the TOG, which expects one summary record per subject, per vaccination, and per event. So this is the high level programming flow of ADCE, which follows OCCD structure. We have not created any new function for this domain in specific. Majorly, it makes reuse of the Admiral core package as it is the basic OCCD structure. So, so the test script here is the template. So as mentioned earlier, we can change or tweak the function call in order to get the desired output for our study. Thank you.
Hi all, this is Arjun Rubalingam from Pfizer. Let's take a look on the ADFAC. ADFAC is also a part of vaccine reactogenicity based on the CBER guidelines. The ADFAC domain has per record, per subject, per vaccination, per event, per time point. The structure of the ADFAC is a combination of BDS and OCDS. And also we have included the link for the CBER guidelines and the talk here. Then the input dataset for the ADFAC is ADSL, phase that is for e-diary data, VS for fever records, and finally we have VX that is for vaccination informations. And coming to the programming flow, we have used the existing Admiral core package functions to certain level, but we had to create new functions to create to get the ADFAC. First, we have derive as merge vaccine. This is to merge the FAC with AX, and also we can retain the required AX variables for the further derivations. If the subject has multiple vaccination at the same visit, this function will not merge the input set with the EX. Next, we have derive fever records. This is to derive the fever record from the VS domain only when we don't have the fever records in our input dataset, which is FACE. Next, we have derive diam to sev record. This function is to derive the severity records from the diameter for the particular administration site events. Next, we have derive as param. This function is to assign the param city values according to the FAT city and FAOBJ. User can pass this lookup dataset as an input inside this lookup dataset argument. Next, we have derive as max flag. This is used to flag the maximum values of an event. First flag is to flag the maximum values per subject per event per vaccination. Second is to flag the maximum values per subject per event for overall. Next, we have derive as event flag. This is to flag the event that occurred. First flag is to flag the records if at least one of the event occurred within the observation period, and second is to flag the record if the event is occurred. And finally, we have post process reactor. This is very specific to ADFAC. So this function is to remove all the values for all the derived records in the SGTM variables. And finally, we have included the example script here for the ADFACE. So like learnings about admiral vaccine is like we had a great experience on the um, learnings through the journey in creating admiral vaccine in R, admiral vaccine package in R. And this admiral vaccine will be useful for us to create the vaccine data sets in an effortless
Hi
manner.
everyone, I'm
Thank
Shukalpo
you.
from Pfizer and I'm the maintainer for the Admiral vaccine package. Let me quickly guide you through the Admiral vaccine website homepage. Admiral vaccine is now available in CRAN and can be installed by running the install.packages command. If you want to install the latest development version of the package from GitHub, you can use this following lines of code. You can copy and execute in your RStudio. Before you get started with Admiral vaccine, we recommend you to go through the function documentations available in reference and also go through the user guides. For any queries, you can reach out to our Slack channel for any informal discussions, Q&A, and also we encourage you to use this GitHub issues link for any direct feedback, enhancements requests, or raising any bugs that you have found. Thank you.